Hi John, how's it going? This is a continuation of the Chapter 15 material, and we're talking about statistics. So just a little bit of a review from last week. We talked about measures of dispersion, so we could use range, we could use interquartile range, we could use standard deviation, which was something new that you probably had not heard of before, and I showed you how to find the standard deviation on your calculator. That is going to be really important, especially for this next topic that we're going to talk about, which is normal distribution. The stuff before that was just mean, median, and mode, and that stuff was pretty easy. So normal distribution is what we're going to start to talk about next, and it's really important. Like, this is hugely important for the unit that we're going to be doing. Normal distribution is the same thing as what people call a bell curve. Now, if you ever hear your teachers say this, or maybe students saying, hey, is this test going to be graded on a curve? A lot of teachers say that all the time. And typically when they say something is going to be graded on a curve, they just mean that they're going to like add points to everybody's grade and bump everybody's grade up. That's not what grading on a curve theoretically is supposed to be. Grading on a curve, or what we call a normal curve, is when you have a small percentage of students who fail, a small percentage of students who get 100, and then the most, or the average of the students are right in the average range, like 60s or 80s, not 60s, like 80s. A normal distribution means that some of the kids did very badly, most of them did very well, and a few of them did extremely well. That's what we call a normal curve, or a normal distribution. So whenever you see or hear a teacher say that they graded on a curve, they're not actually grading on a curve. So that's what we're going to talk about now, normal curve or normal distribution. And let's see. The normal distribution is an important statistical data distribution pattern occurring in, and it occurs in all sorts of things throughout life. It's just that, you know, you never knew what it was, or you never realized it. It occurs in height. It occurs in weight. It occurs in body temperature and blood pressure, in IQ scores, SAT and ACT scores, the life of a light bulb, all this stuff. Just like I said before, let's just talk about height for 1 second. If we're talking about the general population of people, okay, there are a few people in this world who are extremely, extremely short, right? You know, I don't know, midgets or dwarfs or something like that. There are a couple people who are very, very short. For the most part, though, the most, or the majority of the population is about average height, like 5'5" or 5, you know, maybe 6 foot. That's about average height. And then you get towards the other range where there's a couple people in this world who are extremely tall, and they are like, you know, the Shaquille O'Neals, or they play basketball or something, okay? So this is roughly, very roughly, John, this is what a normal curve looks like. It looks like this. And you are going to get used to drawing that a lot. A normal curve, it works like that because you see that this is a very small percentage right down here, and that would be, if we're talking about height, those would be the people who are extremely short, and there's only a little tiny percentage of people who are really short. Up on the other end of the spectrum, there are a couple of people in this world, very small percentage of people, who are very, very tall. And then for the most part, the average population is, you know, average height, and they would live in this kind of area of the curve. So it works the same, like, you know, weight. There's a couple people in this world who are extremely tiny, and a couple people in this world who are extremely large, but for the most part, we're all about average weight, and it works for all these other things too. What I want you to do right now is take a look at your reference sheet, and I'm going to pull it up on the computer again for us so that we can use it. If you take a look at your reference sheet, hopefully you should start noticing that a lot of things on here are getting more familiar to you. For example, we know how to use the area of a triangle formula now. We know how to use law of cosines. We've gone over the sum of two angles. We've gone over the difference of two angles, double angles, half angles, law of sines. We've done sum of arithmetic and geometric series. That was at the beginning of the year. Binomial theorem we will cover next chapter, and then down here all the way at the bottom is what we see, normal curve. That's standard deviation, and that's what we're going to talk about today. But this is the curve. You see how these percentages towards the ends are extremely small percentages? That's kind of like outliers. Those are the really, really short people, and these are the really, really tall people, but the majority of us live up here. And I'm going to explain to you what all of these different numbers and everything mean. But I do want you to have your reference sheet out in front of you while we're going over this, just so that you could kind of have, you know, be able to look at that as we're going, okay? All right. Let's see. Normal distributions are symmetrical with the central peak at the mean of the data. And this right here, right down the middle, is the mean. They are labeling it with a Greek letter, but we use the X bar to signify mean. So always right there, smack dab in the middle, that is the average that you find. So if you're going to find, if you're going to have a question where the data is normally distributed, you're going to draw a normal curve, and then when you figure out what the average or what the mean of the data is, the average is right smack dab right in the middle, okay? The shape of the curve is described as bell-shaped. That's why sometimes you hear it described as bell curve or normal curve or something like that. It apparently is shaped like a bell. I don't know. 50% of the data lies below the mean, so all of this stuff down here, that's 50% of all of your information is below the mean. And then on the other hand, 50% of the information lies above the mean. And we talked about this a little bit before when we were talking about quartiles and percentages and all that kind of stuff. The average or the mean is always the 50th percentile and that means that 50% of the information lies below this line right here, okay? So that's that. The spread of a normal distribution is controlled by standard deviation. Now, we already talked about standard deviation in the previous video. We talked about standard deviation as a measure of dispersion. And remember that dispersion just means how spread apart everything is. So standard deviation is a measure of how spread apart our data points are. So say we're talking about scores that are really, really consistent, like we were talking about those students and their averages. If we have a student who's really consistent and she's always scoring within this small range, the standard deviation is going to be really small because she's really consistent. But if you have a kid who's scoring 60s and 100s and their range is a lot bigger, then their standard deviation is going to be a lot bigger because standard deviation measures how spread apart things are. Okay, so the normal curve is completely controlled by standard deviation. So we had 4 different ways to measure spread or dispersion, but the normal curve only cares about standard deviation. And I'm going to explain that just a little bit more. So here's the normal curve, just like what we had in the previous slide. And the mean is always right here, right in the middle, right where it says 0. And typically you can label it with a 0 or you can label it with X bar, anything you want. But whatever the standard deviation is for your data, you're always going to write that right up here. Let's just say that, let me try to think of an example. Let's say that a student, you know, his scores over the course of the entire quarter are measured on a normal curve, or they are normally distributed. And you use your calculator and you type in every single one of those data points into your calculator, and then you do calculate one variable statistics, and you do L1 and you hit enter, and then you get all that list of information about all those data points. Let's just say that the standard deviation that comes up is a 2. Let's just say, I mean, typically standard deviation has a lot of decimal points coming off of it. Let's just say that it's a 2. And let's also say that his average His average test grade for the whole quarter was probably like an 80, okay? So let me just show you what I mean. Let me show you how we can label this standard deviation or this normal curve. The X bar right here in the middle, that's his average. So I would label this right here as an 80, because that would be his average score. That means 50% of the test scores were below that, 50% of the test scores were above it. So you can see how it says 0 and then 0.5 and 1 and 1.5, 2, all the way up to 3, and then it actually goes in the negative direction all the way down to -3 as well. Those numbers represent how far away you are from the mean. How far away you are from the mean in terms of the standard deviation. So this 1 right here actually represents 1 standard deviation away from the mean. Now our standard deviation was 2 points. So if I'm 1 standard deviation above the mean, that means at the 1 right there, his score would have been an 82. See, because 1 standard deviation represents 2 points. So if I'm 1 standard deviation above the mean, I had to add on 2 points. Now if I'm 2 standard deviations above the mean, that means I'm not just 1, I'm 2 standard deviations above it. I'm going to add on another 2 points, and this is going to be an 84. And then if I go even farther up to 3, this would be an 86. Now I can also go backwards in the other direction. If I'm 1 standard deviation away from the mean, but I'm going backwards in the other direction, that's 80 minus 2. So this is a score of a 78. This is a score of a 76. And this is a 74. And you can get sort of the pattern. So a lot of kids were getting confused when they saw those numbers right there. But the reason why we have to do it is because you're going to use this exact same curve, this exact diagram. This thing is on your reference sheet. You're going to use this for every single statistic question that I could give you. So we need to make it, you know, general. We need to label it with 0, 1, 2, 3, all those things. Because the standard deviation is going to change based on what your question is, based on what your information is, based on what your data is. Okay, so, and obviously we can also go in between by half of a standard deviation. So if 1 full standard deviation is 2, then a half of that is 1. So right here at that line, that would be an 81 in between, and so on. And you could see how that goes, okay? But the mean is always in the middle. And you can go either direction. Yeah. Another really important thing that I want to point out to you is not just the numbers that are below the curve, but the actual numbers that are inside of the curve as well. If you don't believe me, you could take your calculator right now and add up every single one of those percentages. All of those percentages, 0.1, 0.5, 1.7, 4.4, 9.2, 15, 19.1, and so on. They all add up to 100%, okay? Because 100% of our data is represented under this curve. So all of those percentages add up to 100%. So if you are looking for the 50th percentile, obviously, clearly, we already know that the mean or the average is at 50th percentile. But if you weren't sure, if you forgot, you could always take your calculator and add up 0.1, 0.5, 1.7, 4.4, 9.2, 15, 19.1, and all of those numbers added up until that point would add up to 50. So this is the 50th percentile because everything that lies below that line adds up to 50. Now let's try one that's just a little bit harder. Forget about the 50th percentile for 1 second. If you, let's see. Let's try to figure out what percentile this line represents. I don't know what percentile that line represents, but I do know that percentile means all of the percents that are below that line. So what if I take my calculator and I add up all those percents that are below that line? 0.1, 0.5, 1.7, 4.4, and 9.2. So this line right here represents probably about the 16th percentile. And I'm going to just start abbreviating it like this, percentile. That line right there is about the 16th percentile because everything that, if you add up everything below it, that adds up to about 16%.